Of course, it doesn't go anywhere because it's stupid. Of course, you know, I could bring up an AP called Free Public Wi-Fi and start handing out IP addresses, which would give me LAN security domain access to your system. No one would ever do that, though. I mean, who would think to do that? Clients are really, really trusting. You can't authenticate an open network. If you say you're foo, you must be, right? I mean, it's really hard to avoid bad behavior because roaming looks exactly like spoofing a network. Multiple APs with the same network name. Client assumes the network is a common network that you can roam between, picks the strongest AP. The rest of the network doesn't do anything but handle the packets moving over, and the only difference is the MAC address. How many of your users do you think are going to understand how to look at the MAC address of your AP in the network list and figure out if they're connecting to the legitimate one? All right, just pick the strongest network. So if attacker has a stronger radio than the access point, you're probably not talking to who you think you're talking to. As long as the packet goes through, the user will never know. I can check my email. It must be fine. I win. So, you know, two interfaces. One connects to a real network, forwards packets through, connect to a cell phone with EVDO or whatever. The other one provides free public Wi-Fi or, you know, a network that rhymes with FARDUX or whatever. But it sounds really boring to have to make a fate network for every client, and not everyone is looking to join free public Wi-Fi. I mean, almost everyone, but not quite everyone. So we have Karma and Airbase, which go answer all probe requests. I'm an AP. Are you free public Wi-Fi? Yes, I am. Probe response. Network is valid? Come on in. Are you my corporate network? Yes, I am. Request is valid. Come on in. When you're the network, you're the internet. I don't have to own the internet. I have to own your internet. Yes, this is a valid network. Here's your IP. You want to connect to IMAP? Of course you can route to that IP. Log in. You wanted to update Java? Of course. That's not signed. Here's a new update file. Run that as sysadmin. There's a utility called EvilGrade, which actually makes a database of all of the software tools that have updaters that aren't using proper signatures to validate. And you can just bring up a site that provides software updates for everything on a user's system to install as admin very happily. Please log into Twitter. It's a great plan. That's obviously, it's really Twitter. I mean, it's got the image and everything. It's got to be the real Twitter. Log in. Let's make a bad thing a little better. Metasploit. Metasploit plus Airbase plus a massive evil attack framework and a client hijacking system. You wanted Facebook? Here's a face full of browser autopwn and all the exploits that we have just shoved down your throat instead. Many sites encrypt the login, but not the session. Gmail was guilty of this until very recently, where you'd log in. Sure, your password's encrypted, but now your cookie's not. And all that I need is your IP address, which I have because I'm next to you, and your cookie, which I have because you just sent it in the clear. And now I have your email, which I'd also have because I watched you reading it anyway, but now I can log in as you. But all these are still kind of boring because they're really obvious. You'll probably get users. They'll all work. They're great. But it'll be really obvious. If someone is looking, they'll see another AP come up and start screwing with their network. I think points are awarded for style and stealth. So wait a minute. Didn't we say 802.11 is shared media? Yeah. We found the best time machine ever made. And it's not a hippie do-gooder time machine. But it's one where we get to go to the future and bring back awesome weapons with us. So with bad old days, hair metal, grunge, ripped jeans, unswitched Ethernet, sniffing the entire segment, TCP session hijacking. Renderman and I gave this talk in Poland, by the way, and I went to hit this slide. I'm like, remember the bad old days in the 80s and grunge metal and ripped jeans? And oh no, it's communism. I can't show this slide. But it'd never be that easy, right? I mean, people have to have gotten smarter about it now. People would not make all the mistakes they made in the 80s and 90s with shared media networks. You'd never take a system from a secured internal network to a completely insecure shared media network, would you? Oh, you would. So, remember, management frames have no protection. Open networks have no client protection. Nothing stops us from being the AP and talking to the client as if we were the AP. So you can try to filter inter-client stuff on the AP. And it works good if you have an encrypted network. It doesn't work so good if you don't, because, okay, client A can't talk to client B. Too bad I'm the AP talking to client B now. Can't filter that. Just generate an 802.11 header where the from MAC address is the AP, the to MAC address is the client, and, oh, look, the client thinks the packet is legit. There's no way that the AP can stop that from happening because you're spoofing the AP. And we can communicate directly with protected clients, because they're not protected, because it's all crap. So most modern cards now use soft MAC layers, where all of the control of the Wi-Fi stuff and the packet creation is offloaded to the OS. Older cards like the Prism 2 and whatnot, the early 2000 cards, had all that stuff in the firmware, so you couldn't do really fun packet creation, because when you tried to put it in there, the firmware went, oh, I know how to make that packet, and overrode everything you did. So only certain timing critical stuff is handled in the firmware, sometimes not even that. And that means we can send anything we damn well want, usually. Unfortunately, there aren't any real standards for injection. Every operating system does them differently. All the drivers do it differently. Sometimes you need custom headers on the packets and all that. So Josh and I went, hey, writing the same code over and over again really sucks. Writing custom code for every driver sucks. Writing custom apps for every OS sucks. So we made Lorcon, which unifies all the packet injection. Unfortunately, the API kind of sucked. So we redid it. So there's a new API that's modeled off PCAP. It's designed to be super, super easy to use. C, Ruby, someone's working on a Python API. It'll soon support all the cards Lorcon 1 did. For now, it supports the kernel drivers in Linux and the Mad Wi-Fi drivers. The URL will be at the end of the presentation again. So it's super simple. It automatically determines the driver. It automatically configures virtual network interfaces for injection. You can send arbitrary bytes, or you can build packets with a little simple packet creation API where you go, insert these fields, make this type of packet, do that, add the checksum, go ruin someone's day. So, I mean, it really is this basic, and this is the C version, not the Ruby version even, where you just make a driver, identify or find the driver for the interface, create the context, open it in monitor inject mode, set the channel to channel 6, and send a whole bunch of crap. Done. That's all you need to do, Depending on what your payload was, that's a network DOS right there. So the inspiration for all this, Wi-Fi session hijacking. About 5 years ago, Toast debuted AirPwn at DEF CON. It was TCP stream hijacking in 802.11. This is the most awesome thing ever, and no one noticed, and everyone forgot about it. And it's not just for shock porn anymore. Think about it, and if you don't get it, I'm sure the person next to you will be happy to explain it to you. So, rerouting TCP streams. It's a typical layer 2 attack. TCP is only secure because the sequence and ACK number aren't known. If you're unencrypted and I'm on your shared media network, I see your sequence and ACK numbers. Any TCP stream is subject to abuse. So what does it look like? SYNAC, blah, 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 handshake. Client goes to the server, says, get this web page, sequence number, whatever, ACK number, whatever. Server says to the client, here's your headers, here's your content, here's your sequence number, here's your incremented ACK number. So let's add this to Metasploit, because that's a good idea. Let's take something terrible and add it to something really awesomely terrible. So there's a Ruby wrapper. Uses Racket for packet assembly. It's high-speed packet assembly in Ruby. Ruby PCAP and a little loving care, and you get Metasploit. So the anatomy of the evil session would be handshake. Client says to the server, get this, the numbers, and the Metasploit says to the client, here's your data, and the numbers line up. And end that connection. You're done. And then it says to the remote server, and end your connection. The client went away. You're all set. I'm the router. It's okay. Just go away. I'm done. Server says to the original server says to the client, here's your real data. And the client goes, those numbers don't line up, and just throws it on the floor. So how easy is this to do in Metasploit? Load the AirPwn module, set your interface, set the response you want to overload it with, and run it. And, oh, look, there is someone looking at the Racket documentation. Yeah, that was my own network doing it against myself, but So that's all you need to do web page hijacking in Metasploit. So what else can we do? We can do match and replace in regex. The response can be full JavaScript files, image replacements, HTML, another arbitrary file. There's a YAML config file where you can do regex matches against specific requests. So you can build lists of known poisonable files like jQuery. It'll automatically generate HTTP headers as needed for arbitrary data you give it. It gives you complete control of the page content, including headers. So what does that get us? That gets us HTTP content replacement. We can control the page DOM. That means we can control your forms, we can control your browser, we control your iframes, we can access anything in the security context of the page we injected code into. So we can replace content. What do we do now? All the sites include a crap ton of shitty little JavaScript helper files. What happens if we replace one of them that the user would never see? I wonder. I mean, obviously CNN needs all those JavaScript files to work, right? So JavaScript fragments, they're really, really attractive to this because the user never sees them. and they get asked for a lot.